So we're looking at how to do a written check of your solution. And the first thing I want you to do is to copy this problem, more or less down. Bubba and Bertha are math partners, and they both solved the following equation. You could write something like Bubba and Bertha solved the following equation. Copy the equation down. Yes, Luke?
Is that Bubba and Nan's Bertha?
Yep. So, like often happens when you have to do something with your partner, right? You both finish and you check and you have different answers. Well, that happened to Bubba and Bertha. Bubba gets the solution of x equals negative 26, and Bertha gets x equals 7. How can we check if either is correct without actually solving the equation? Without actually going back and just solving the equation? Bobby?
Well, you could, yeah, you could look at the, how you could, like, almost, how you would add the opposite.
Okay, that's true, but there's another way too, based on the fact that we talked about a solution. What's the definition of a solution? Caitlin?
The answer to a multiplication problem.
Oh, you're thinking product.
Wait, solution is, addition.
We just got this when we did beginning equation solving. You want to flip back. What you got for it? Here it is? No. Jack.
The answer to
Well, we said something more specific than that. Are you looking at it, Luke?
The value of the variable.
The value of the variable, Mary, that makes the statement true. So when Bubba solved this and got x equals negative 26, that means that this value, negative 26, should make this statement true. What do we do to check? Will?
Well, I just noticed that negative 2x is negative, and the opposite constant equal sign is not negative. So even if you were to get an answer, the side right for the whole sign, it has to be negative.
Okay,
Yeah.
all right. But what can we do to be really precise? If x equals negative 26, and I've got an x right here in this equation, what should I do?
Oh,
Zero? Yeah, take that value, negative 26, plug it in for x, and see if you have a true statement. That's how we can check it. So substitute the value into the equation and check if it becomes true. So Bubba thinks it's negative 26, and Will, this will kind of show up where what you're talking about. We're going to check his solution of x equals negative 26. We look at the original equation, and if it is a good solution, it'll make a true statement when we plug it in. So substitute negative 26 for x, and see, does it equal 19? Well, what's negative 2 plus, or not plus, times negative 26? What is that equal to? Can you tell me, Baishu?
that's 52.
52.
No, just 50.
Yeah, just positive 52. Is 52 plus 33, does that equal 19?
No.
No, nowhere close, right? That's 85. 85 does not equal 19. So when I plugged in negative 26 for x, did it make this equation true? No. 85 is not equal to 19. That's not true. So that tells us that Bubba's wrong. And that's how you can check any equation. Substitute the value in and see what happens. Let's try it for Bertha's value. Let's check Bertha's value of x is equal to 7. Well, our original equation is here. We want to see if it's true when we plug in Bertha's value of 7. So we substitute it in, and we see if it equals 19. What's negative 2 times 7? Caitlin?
Negative 14.
Good. And what's negative 14 plus 33? Daryl? 19 equals 19. Is that a true statement? Does 19 equal 19? Yes. So it's true. That means that Bertha's solution is correct. X equals 7. Because when we plug 7 in, we get a true statement. Now, some kids get a little confused. They're feeling like they should be getting 7 down here. No, it has nothing to do with it. If you plug 7 in and it's the right solution, you will get a true statement at the bottom. All right, that's what we're looking for. Any questions so far? All right, so let's look at another equation. All right, the equation is, so let me back up a step. The directions usually are going to be solve the following equations and do the written check. So you're going to do both. It's checking to see if you understand that you're solving for an unknown, and then understand that that unknown should make it true if it's correct. So we're going to solve this equation. 3 times the sum of x and 5 equals 27. I want you and your partner to take a minute and solve that equation and then stop. Okay, so we're going to check in. We take these steps down. You solved it. What did you get as your solution, Morgan?
I got x equals 4.
All right, so we're going to check and see if x equals 4 is correct or not. All right, so we're going to do the check over here, but let's first write down these couple of important points about checking your equation. First of all, we want to always check in the original equation. As soon as you start doing something to your equation, you don't want to check your solution in it, because if you make a mistake manipulating your equation, then your check's not guaranteed to turn out. So always substitute in to the original equation for the check. What do you think the next phrase is supposed to be? Follow the blank of blank. Anna?
Order of operations.
Yeah. When you do the check, you're simplifying with the order of operations. You gotta take yourself out of equation solving mode and put yourself in simplifying mode. Okay? So we're gonna check Miletus says x equals 4 and see if he's right or not. We always check it in the original equation. So that's right, we're checking x equals 4. So the very first and only thing you should do in your first step is substitute in that value. And we want to find out if it makes a true statement. Now listen, this is where kids start doing something I don't want you to do. This is distributive property here, but neither of these are variables. There's no reason to distribute. You can just simplify. If you were looking at this side of the equation and it was an order of operations problem, what would you do first? Caitlin?
4 plus 5.
Yeah, what's in parentheses, and what's that equal to, Caitlin?
5.
So we did 3 times 9, and we're trying to figure out if that's true, if it equals 27. What's 3 times 9, Mikey? Is this a true statement that 27 equals 27?
Yeah.
Yes. That means that Miletus was correct. X equals 4. All right? Are there any questions? Okay, now here's the other thing. Again, when you plug in your value, your solution, this should work itself out. It's not going to be the same as your value of your variable. It's going to just be some other statement. Here's what happens though. Kids get smart, and on a test, you're going to have to do both these things. You're going to have to solve and then check. And kids get smart. They know that it's supposed to work out to something equals something. But they make a mistake, and so then they do what I call is fudging the check. They like go down this side, and they're like, maybe they ended up with 3 times 8, and it's like 24 equals 27, and they know something's wrong, but they just go, that's right, let's pretend, and they make 27 equals 27, check. But Mrs. Doble checks your check, okay? So you don't want to fudge it. You're better off, if it comes up with an untrue statement, there's something wrong. Go back and find out what's wrong. And if you can't find it, then your best bet is just to write a little note. Something's wrong, but I can't find my error. Don't fudge the check. Okay.
I like
I love chunky.
Here's the other thing. If you solved it correctly, I know what this bottom line should come out to be. So I look to make sure that that's coming out to what it's supposed to be coming out to too. All right, we got one more problem. Let's take a look.
You're gonna get the math all year. Come on, guys.
All right,
Come
so
on, guys, fast.
this is a little bit more complicated equation, and we're gonna work through it together because there's some important points I wanna point out when these equations get more complicated. So you're copying down 4 times the difference of 2m and 5 minus m plus 8 equals negative 54.
This is
Oh, this is
true.
All right.
I'm so busy.
So what's the first thing that we should do here? What's the first thing that you wanna do? Luke?
4 times the difference of 4.
Good. What do you get when you multiply that?
8m minus 40.
Good, and then I'm going to just copy down the rest of the equation. Okay, here's where the weirdness can start. Kids will start to solve this piece by piece with all of these terms here on the left. You should not do that. You should just simplify the left side first. So in the margin, I want everyone to write simplify before solving. I have proof that I emphasize this to you. Don't start to solve this until you've simplified both sides of the equation as much as possible. So if there's any like terms, combine the like terms. Jack?
So could you subtract m from 8m?
Yes, and you would get
7m.
good. And anything else, Jack?
You can add 8 to negative 20.
And what do you get?
Negative 12.
Good. So this is the same as 7m minus 12 equals negative 50. Now it's a nice simple equation. Now solve it. And what's the next step, Robbie?
You add, so to eliminate the constant, 7 plus negative 12 plus 12 equals negative 4 plus 12.
Good.
And then you get 7m equals 42.
Positive or negative?
Negative.
And what's the last step that we need to take here, Novacek?
Get rid of 7.
How do we get rid of it, though? What operation? Divide. Okay. So m is equal to what, Daryl?
And equals negative 6.
All right. So now we have a solution. We think it's good, but we're not sure, so we're going to check it. We check it in our original equation, and here you really got to be careful. Notice our solution is negative, and our equation's got a lot of subtraction, so you're going to have to be on your toes that you're not making any sign errors. So here we go. Into the original equation, I'm going to put this. So I'm going to have 2 times negative 6 minus 5 minus, now watch, minus, m is negative 6, so it's minus negative 6 plus 8, and we're wondering, does that equal negative 54?
Oh, you have to take out all the variables?
That's what checking is. It's taking the value of the variable you got and putting it into the variable to see if it's true. All right, so we got a big old mess on the left side. Simplify it with the order of operations. What's the first thing we should do over there? The first thing. Logan?
The middle.
The middle, what do you mean?
2 times 6.
2 times negative 6. Yep. You got to go into parentheses and do the multiplication in there. What is 2 times negative 6, Logan?
12.
Positive or negative? I'm going to change this minus and negative. What am I going to change it to, Anna?
Plus.
Okay. Now what should I do next as I continue to simplify using the order of operations, Caitlin?
You said distribute 4.
We could distribute, but we can just follow the order of operations. So what's the other thing we can do?
Add.
Yeah, in these parentheses, can we do what's in parentheses? What's negative 12 minus 5? Yeah. So that's what I mean by follow the order of operations. Rather than distributing in that situation, just simplify it. Okay. Now what? If I'm continuing to follow the order of operations, Mikey?
You had 6 and 8.
Well,
wait,
technically, no.
You multiply 4 and negative 17.
What do you get?
You get negative 4 Negative 68.
Good. And then we want to see, we're almost there, does it equal negative 54?
Easy way to do this is negative 68 and 8 is just negative 60.
Plus 6 gives us what? What give us, Daryl?
Negative 58.
Negative 68 and 8 is negative 60. And negative 60 plus 6 is
Isn't that 6 negative?
this one?
Yeah, but-
No, because it's minus a negative, which is
Oh,
the
yeah,
same as
yeah,
plus. I'm glad you asked. All right, so Anna, is negative 54 equal to negative 54? Yes. Woo, thank goodness, because that was a lot of work. That means my solution of negative 6 is correct. Yay. Jack?
I did it a different way where I got negative 68 equals negative 60.
Oh, you started to solve at some point during the process. You didn't just simplify. And that's something that kids fall into a lot. That's why I keep emphasizing just simplify, don't solve. Okay? All right, so we are going to practice with math ball.